Hi everyone, in this video I'm going to show you how to use trig ratios to solve for the missing side in a right triangle. So in this triangle DEF we're given the angle D, which is 73 degrees, and then we're given the side DF, which is the length of 27, and we're looking to find the side which is labeled X. That's our missing side. So first of all, some of you might be wondering, why can't we use the Pythagorean theorem to solve for this missing side? The reason for that is because we don't know the length of the longest side, the hypotenuse. We only know the length of the leg at the bottom of the triangle. In order to use the Pythagorean theorem, we would need to know two side lengths in order to solve for the third missing side length. So in this triangle, we only know one of the side lengths, but we're still looking for another side length. That means we have to use our trig functions. We have to use SOHCAHTOA. So our first step is to label the missing side we're looking for and the side we've been given based on the angle we've been given. Of course, we always know our right angle is 90 degrees, but we are going to label the sides based on the other angle we've been given, the angle that is not the right angle. So we're focusing in on the 73-degree angle D. And we want to label the side we're looking for and the side we know. So the side we're looking for is X, which is across from angle D, which means it's our opposite side. So we're going to label it as the opposite side. And then the side we've been given is the leg at the bottom, 27. So it's either going to be adjacent or hypotenuse. Of course, our hypotenuse is always that longest diagonal side. So this has to be our adjacent side. Remember, adjacent means next to. So since 27, this side is right next to our angle, that means it's the adjacent side, but it's not the hypotenuse. The hypotenuse always is the same longest diagonal side in our right triangle. So now that we've labeled the missing side as opposite and the known side as adjacent, we can figure out which trig function uses both the opposite and the adjacent side. So we're going to look at SOHCAHTOA to help us figure this out. Remember, the S stands for sine, which uses the opposite and hypotenuse. That's the SOH. The CAH stands for cosine, which uses the adjacent and hypotenuse sides. And then T stands for tangent, which uses the opposite and adjacent sides. That's what the TOA stands for. So we want the trig function that uses opposite and adjacent, so O and A. So that means we're going to use the TOA part of SOHCAHTOA. So T stands for tangent. So this tells us that tangent of our angle theta is equal to the opposite over the adjacent side. So now we're going to use this ratio to write an equation and then solve for X. So we're going to write tangent of the angle we've been given, which is 73 degrees, equals the opposite side, which is X, over the adjacent side, which we said is 27. So now we have an equation with only one variable, X, which means we can solve for X. So this is only a one-step equation, luckily. So we have tangent of 73 degrees equals X over 27. If I want to solve for X, that means I'm trying to get X by itself. Right now, X is being divided by 27. We want to get rid of that division by multiplying by 27 on both sides. So my 27 is going to cancel out on the right side. Now we have 27 times tangent of 73 degrees equals X. Now all I have to do is I need to use a calculator, put 27 tangent of 73 degrees in the calculator, and it'll give me a decimal, which we're going to round to the nearest tenths place because that's what you have to do on the Delta Math assignment. So if you don't already have it pulled up or you don't have a scientific calculator you like to use, go to desmos.com/scientific, and that will be a really good calculator for you to use. You always want to make sure it's in degree mode because we're putting in a degree. It's automatically in degree mode, but it's always good just to double check because in the future we will use radian mode when we're using radians in the future. So we're going to go to that website and type in 27 tangent of 73 degrees. So here we are, and I can tell that it's in degree mode because you can see this switch right here. You can switch it back and forth. It says DEG, which means it's in degree mode. So I'm just going to type 27 tangent 73. We don't have to type degrees because it already knows we're in degree mode. We get 88.3130207. And to round this to the nearest tenths place, we're going to use the 88.31. Since 1 is below 4, that means we leave 3 as it is. So 88.3 is our answer. So 88.3 is the missing side length for X. All right, we're going to do two more. So let's go on to the next one. So for this next triangle, the angle we've been given besides the right angle is 72 degrees, angle T here. And then the side we're looking for is the missing side X, and then we've been given the side 6.6. So we need to label the missing side and the given side based on where they are in relation to the angle 72 degrees. So X, of course, X is on my longest diagonal side, so X is the hypotenuse. It doesn't matter if I was looking at a different angle in the triangle, this longest side is always the hypotenuse, no matter which angle you're looking at. So that has to be the hypotenuse, and then the side we've been given, 6.6, it's right next to our angle, so that means it is the adjacent side. So now that we've labeled it as the hypotenuse and the adjacent, we need to pick which trig function uses these two sides. So A for adjacent, H for hypotenuse. So I'm looking for AH. That is going to be the part of SOHCAHTOA. The C stands for cosine. So that means we're going to be using cosine of our angle equals adjacent over hypotenuse. So now we're just going to use that to set up our equation. So cosine of 72 degrees equals adjacent, which is 6.6, over the hypotenuse, which is X. So this one's a little different because this times X is in the denominator. And if we want to solve for X, we're definitely going to need to get X on top into the numerator. So my first step is going to be, I want to get X on top so that we can solve for X. Right now it's in the denominator, so to move it to the top, we're going to multiply both sides by X. So now the X is going to be in the numerator on the left side instead of in the denominator on the right side. It'll cancel out over there. So now we have X times cosine of 72 degrees equals 6.6. Now X still is not by itself, so we have one more step. To get X by itself right now, it's multiplying with cosine of 72 degrees, so we need to divide both sides by cosine of 72 degrees. I want to remind you that cosine and sine and tangent are trig functions, and they don't mean anything unless there's an angle inside of them. So don't ever try and divide by like just cosine. That won't work because cosine by itself isn't a number, it's just a function. It only gives us a number when we plug an angle into it. So that's why we have to divide by cosine of 72 degrees. So when I do that, it cancels out on the left side, so I'm left with X, which is what I wanted, which is 6.6 over cosine of 72 degrees. So of course I'm going to need a calculator. I'm going to go back to my calculator. It's still in degree mode. And I'm going to put in 6.6 divided by cosine of 72. And it knows it's in degree mode. We get 21.358. So to round to the nearest tenths place, I want to look at the number after the tenths place, which is 5. Since it's 5 or above, give it a shove. That's the rule. That means it's going to be 21 point. We're going to shove that 3 up to a 4. So 21.4. So X equals 21.4. And that's our missing side length, the missing hypotenuse for this triangle. Let's do one more. So for this triangle, we are given the angle R, which is 24 degrees. And let's label the side we're looking for, X, and then the side we've been given, which is 3.8. So the side we're looking for is right across from our angle. So that means it's the opposite side. And then the side we've been given is the long diagonal side, so that's our hypotenuse. So we need to pick the trig function that uses the opposite and the hypotenuse. So O and H, that's going to be so, and the S stands for sine. So we're going to be using sine of our angle equals the opposite over the hypotenuse. So let's go ahead and write our equation using that. So sine of the angle we've been given, 24 degrees, equals the opposite X over the hypotenuse, 3.8. So we're back to that one-step situation because X is already on top, so we don't need to multiply by X on both sides. It's already on top, so we just need to get rid of the division by 3.8, which we'll do by multiplying by 3.8 on both sides. So it cancels out on the right, and then I have 3.8 sine of 24 degrees equals X. So now I just have to put, X is by itself, I just have to put 3.8 sine of 24 in my calculator. So 3.8 sine of 24, that gives us 1.545599244. So when I look at the number after the tenths place, it's a 4. 4 or below means let it go. So I leave it at 1.5. I don't need to push it up to another number. So 1.5 equals x. So that's our missing side length, the missing opposite side from 24 degrees. So as you can see, we did one example with tangent, one with cosine, and one with sine. We did 2 examples where x was in the numerator and then one where it was in the denominator. So you can see how to do it both ways. Just make sure you follow the steps and you'll be good to go.